All right, let's go over numbers 25 through 30 now from Final Exam Review 2. All right, write a null and an alternative hypothesis for the situation described above. The thing I want you to always have in the back of your mind is that the null is always the one with the equal sign. The equal sign never goes to the alternative. Write a null and alternative hypothesis for the situation described. Particular compound in drinking water is not hazardous if it is present in 29 parts per million or less. An environmental watchdog group believes a particular supply does not meet this criteria. So we want to test and see if it's greater. The null is that it's less than or equal to 29, and the alternative is that it's actually greater than 29. What's a p-value represent? It's a probability. What are the smallest and largest possible p-values? Well, the probability, p, is always between 0 and 1 inclusive. So it's p is greater than or equal to 0, less than or equal to 1. Is negative 0.5 possible? No. 0.5? Yes. You can't have negative numbers for probabilities. What about 1.5? Absolutely not. You can't have a probability greater than 1. Okay, number 27. Change to 300 students and a mean of 7.5 hours. So a survey of 300 students provides a sample mean of 7.5 hours worked. What is a 90% confidence interval based on this sample? So to find the confidence interval, it's everything in between the two split ends of this. So 1 minus 0.9 is 0.1. Then I split that in half to get the two white pieces on either side, and they're 0.05. So I do second bar's inverse norm of 0.05 with 0 and 1. That's the z-score way of doing things. 0 mean, 1 standard deviation. And I get negative 1.645. So that begins my error-bound calculation. 1.645 times the standard deviation, which is 2, divided by the square root of 300. That's your SE right there. And that gives you 0.19 when you're done cranking out all that multiplication. So you are bound around the mean, which is 7.5, and you're going to go down 0.19 and up 0.19. So for a 90% confidence interval, you are between 7.31 and 7.69. Number 28, change the p-value to 0.033. How does it relate to 0.10, 0.05, and 0.01? Well, 0.10 is greater than 0.033. So if the null is, if p is low, the null must go. Next one, 0.05 is also greater than 0.033. So the null must go. Lastly, 0.033 is greater than 0.01. So then the null must fly. Okay, number 29, type 1 and type 2 errors. I personally think that of all the things I tried to teach you this year, the thing I struggled with the most was type 1 and type 2 errors. It's not that I couldn't say which ones they were. It's I couldn't come up with a clean way to say it so that it's rememberable. Now I think I do. Type 1 errors only occur, and they always occur, when the null is true. Type 2, when the null is false. And you got to remember, in order to be an error, it has to be wrong. If the reasoning is correct, it's not a problem. So for instance, if we said the parachute is safe when in fact the parachute is safe, that can't possibly be an error. It's a valid statement, okay? So state 4 possible outcomes when considering the null hypothesis that a blood pressure drug is safe. So 1 is, don't pay attention to valid type 1, type 2 yet. Let's just look at the statements. The drug is safe when in fact it is safe. The drug is not safe when in fact it is safe. The drug is safe when in fact it's not safe. And the drug is not safe when in fact it's not safe. So if we look at the first and the last ones, they're valid reasonings. The drug is safe when it's safe. Okay, the drug's not safe when it's not safe. So those can't possibly be errors. Those are valid reasoning, or examples of valid reasoning. The type 1 error occurs when and only when the null statement's true. So the mistake is to say it's not safe when it is safe, because that makes the null statements true. Okay, type 1 error, the drug is not safe when in fact it is safe. The type 2 error occurs when the null is false. So it only occurs when the drug is not safe. So the only way to make a mistake if the drug is not safe is to conclude that it actually is safe. So the type 2 error is when you conclude the drug is safe when in fact it's not safe. Okay. Number 30, baseball statistics analyst or statistician, if you want, wants to see if the mean number of home runs per team is greater than 185. should she perform a one or two-tailed test? Definitely want to do a one-tailed because it's only greater than. See, when you do a two-tailed test, you're testing both ends of the normal curve. You're only looking at the greater end here. So it's a one-tailed test. And it's not the same. The results wouldn't be the same because you would have the answer from two tails, which is clearly going to be greater than the answer from one tail. Number 31. Last year, the government turns around and makes this proclamation. I would just hold this up because we're almost done with the video time here. It's a z-test. You have to, for input, you're going to use stats. The null is 34,500. Standard deviation is 1,003. The mean is 34,375. There's 30 in the sample space. We want to test that it's not equal to, okay? We want to test that it is not equal to. That's what it says in the problem. P works out to be 0.495. That's a lot bigger than 0.01. If P is high, the null must fly. The average income is 34,500. Have a fantastic day, everybody. That's the end of sheet 2.